It's a lot of stuff you already know in one problem. It's not really hard to know.
It's
To
long.
answer your question, but I've been doing calculus for 20 years, so
It's long with numbers.
take that with a grain of salt, I guess. Okay, so yesterday what we looked at was mostly problems where a function went out to the infinite, like 1 over x. We would calculate the integral from 0 to infinity of 1 over x, right? We can have a similar calculation where we don't explicitly put the infinity symbol in the problem, but we have a discontinuity. Okay, so a similar problem based on this would be 0 to 1. 1 over x dx. There is an infinite discontinuity. X equals 0, right? So we have to tackle those in a very similar manner that we did yesterday. You might think of a way to write that problem using a limit, like we did yesterday, to make it a more proper integral to solve. We can't put 0 because we have discontinuity there. That would violate the condition of a definite integral.
Negative infinity to 1?
No. We need to start 0. How would you write that as a limit?
I mean, as x approaches, or r approaches negative infinity?
What number are we approaching?
0.
Oh,
0. From what side?
So
the
that,
left. No.
The right. So we're approaching 0 from the right, correct?
Yes.
Okay, so that's what we need to put, and then r to 1. Okay, because again, 0 cannot be in there because one of the assumptions of calculating definite integrals is that the function is continuous. Okay. So in order to satisfy that requirement, we have to change this to a limit. Okay. All right, so natural log absolute value x. Now, thinking again about our limit, what do we get for an answer?
is this one the one that diverges?
It is. Can you explain why?
Because natural log at r, or as it approaches 0, however you want to say it.
As r approaches 0 from the right.
Yeah, isn't it like infinity? It's not real.
Negative,
There you go.
quote unquote. So we get divergence because that's basically positive infinity, right?
Sure.
Okay, so this area goes to infinity. Like You keep counting and counting, the closer and closer you get to zero, you keep counting up area, and it goes to infinity.
Can't you diverge if it's just negative infinity as well?
Yeah, it would just be assigned area, like the area is under the x-axis is what that would mean mathematically. Good. So pay attention to those, they might have an infinite discontinuity in them. Here's another one. You see the problem with this one?
You can't do it.
You can, actually. It's improper. Why is it improper?
It's fun, right?
Look at the integral limits and look at the function and see if there's an issue. It's okay, but
One over
1 over 0 is not okay. So where's the issue?
At the one.
At 1. There's an infinite discontinuity at x equals 1, right?
Sure.
Yeah, you good? Sure. That's not very encouraging. Yeah, plug 1 in, you get 1 over 0 discontinuity. So this is an infinite discontinuity.
So like this work is you start R approaching the where everything.
Yeah, so the limit as r approaches what?
1.
From the
0 to R. Oh, from the right. Left.
Right. So negative.
left. Okay, 0 to 1.
Yeah.
Remember your integrals? Do you have them memorized? You've been doing your memory cards?
That's gonna be like sine.
It's
What
more. Sine what?
do you mean sine what?
Sine inverse.
Sine x.
Sine x?
And
No, the derivative of that
No,
is
inverse.
cosine.
Ah. Yeah, it'd be sine inverse.
There you go. Yeah, sine inverse x. Yeah.
Why not? The arcs and the inverse are the same, correct?
Yeah, like arctan.
Yeah.
Yeah, those are the same.
Yeah, that's. There we go.
I don't know how to evaluate sine inverse.
One
So-
over whatever sine is.
Whatever, so sine inverse
It's just 1 over sine.
at 0 is asking you where is sine x 0.
And then you have to solve for the x.
Right.
Oh, so it'd be
What are the unit circle, where is sine 0?
0 and 180. So pi and
Pi and 0, okay,
over
thank you.
2.
Okay, so this would be 0 because pi is outside of 0 to 1. Pi is 3.
Pi over 2,
Right.
right? Wait. No, it'd be 2.
You're good, 0.
What? No, because there's 2 points for it.
Yeah, at pi, right? 0 and pi.
180 is 5.
Oh, yeah, okay, yeah.
But that is outside of this interval that we're working with.
Half pi, full pi.
Okay.
Pi is outside 0 to 1, so we're not worried about it.
Not 3/4
Okay,
of pi.
now, whether this our approach is 1 from the left,
I don't know what that means.
or sine inverse of r, well, what's our first attempt on a limit?
Oh, probably
Plug and chug. So where is sine x 1?
pi over 2 and 2.
3 pi over 2. Why would you do those values instead of that? Did it pi and 3 over 2?
It's outside the domain
Yeah,
of
3 pi over 2.
Oh, because it goes from
our
0 to
inner
0.
limits.
Gotcha.
Wait, but pi over 2 is between 0 and 1?
No, it's not, actually. I might have explained that wrong. It's not actually an x value calculation. You... Why would we use?
Is it because at pi it's negative 0?
These are, so, okay, take a look at that. We are confusing x and y values. Right. Your,
At 3 pi over 2 it's negative 1. Correct.
sine is.
Yeah, so you don't want that.
We're working within the x values of 0 to 1,
Yes.
correct? Those would be our coordinates. Right, sine 0 to 1. What angles fall within that purview?
0 and negative.
0, 5.
That explanation makes sense.
0.
So are we limited in reference to sine? Because that's an problem.
That's what we're looking at.
So with how you're saying you have to stay between 0 and 1, it's in relation to sine? Like,
Right.
so it's not the actual value, it's what sine puts out when you put the values in? Yeah. What if you get like cosine and sine in there?
Then you
Then
correct.
you have to find it.
Don't cry. It's not possible.
It's not?
No, we're not gonna get you. That's gonna be a calculator-based problem. Any questions? Do you need me to write the work down again?
Yes, please.
Holy smokes, class time to do homework? I might get it done.
I know, part of the reason I give you this
Double down.
second day.
And grab my book. Of course, nice.
I have to watch it. Because I can do any of 7.
I brought it into my house to do it. That's funny.